Hello everyone, welcome to Pepcoding. In this video, we are going to look at our question, friends pairing. So let's see. In this question, we are given a number n, right? And this n represents the number of friends. So for n equals to, let's say 4, we would have four friends. Let's call them 1, 2, 3, and 4. Okay. Now in this question, let's assume that all of these friends are going to a party, right? They're going to a party and they can either go in pairs or they can go as singular, okay, or they can go alone or they can either go in pairs, right? So if they are going alone, we can say that they are going like this, right? All of them can go alone, right? So this is going to be one way. This is going to be a way in which they are going to go to the party, right? This can also be a way. 1 and 2 are going in a pair, 3 and 4 are going alone, right? This is also a way. This is also a way that 1 is going alone, 2 and 3 are going in pairs, 4 is going alone, right? This is not a pair. This is not a valid way, 2, 3, and 4, because now they are not going in a pair. They are going in a group, right? And we are not considering groups. We are only considering pairs. Okay, so this is not a valid answer. So we would have here, we can have something like 2 and 3 are going in a pair, 1 and 4 are also going in a pair, right? So this is also my answer. Similarly, there are going to be many answers, right? So what I have to do for this question, what I have to do is I have to find all the ways, or I have to find the count of the ways in which all of these friends can go, okay, or all of these friends can go to the party or whatever they are going to. Okay, so let's say I have two friends, right? So either they can go alone, right? They can either go alone or they can go in pairs, right? So I hope you understand this question, and let's see how we are going to solve this. Okay, let's draw a table. We have something like this. Let's say this is going to be my total number of ways. So total ways here. Okay, and here let's mark them 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, something like this. Now let's see for 1. Let's see for 1, right? If 1 wants to go to a party, and this is a single guy, right? This is a single guy. If 1 wants to go to a party, he cannot pair up with someone, right? Because he's already alone. So the only way he can go to the party is if he go alone, right? He cannot pair up with someone. If there is just one person, he cannot pair up with someone. So the only way he can go is alone. So the ways, the total number of ways, if my value is 1, is going to be 1. If my n is equals to 1, the total number of ways that my friend that I can go is 1 for 1. Okay, I hope you understand this part. Let's see this for n equals to 2. Okay, for n equals to 2, I have, let's say, two friends, 1 and 2. Okay, I have 1 and 2. Now 1 and 2 can either go alone or they can go in pairs, right? If 1 and 2 decide to go alone, they can go like this, right? Both of them are going alone. But if they decide to go in pairs, we would have 1 and 2, right? 1 and 2 both in pair. But we cannot have something like 1 and 2 is paired up with someone, because there are only two people, right? So the only ways for two people to go would be either alone or either in pair, right? So the total number of ways would be 1 here, 1 here, and this would be 1 plus 1, 2. Okay, total number of ways for n equals to 2 would be 2, because one way would be they are both going alone, or the second way would be they are both in a pair. Okay, I hope this point is clear, because now these two parts, this for n equals to 1 and n equals to 2, these are going to be my base cases. So I would assume that this part is clear because this is very easy, and we are going to build our next answers on these two bases only. Okay. So let's see for n equals to 3. For n equals to 3, I have, let's say, 3 friends, 1, 2, and 3. Right? Now, let's separate 3 from these two friends, and let's see for 1 and 2. Right? For 1 and 2, we already know what the answer is. Right? If 1 and 2 decide to go, we already know that they can either go like this or they can go in pairs. Right? So the only two ways for 1 and 2 would be they both go alone or they go in pair. Right? This would be my answer for 1 and 2. But now I have introduced one more character or one more friend. Right? So what would happen? Let's see. Let's see. Let's say that 3 decides to go alone. Right? They can either go alone or they can go in pairs. Right? So let's say 3 decides to go alone. If 3 decides to go alone, 3 is deciding to go alone, then we would only care for these numbers, because we would only care for these friends, right? Because since 3 is going to go alone, all of the friends which are n minus 1 or which are 1 and 2, I'm only dependent on them, right? Let's say I have 1 and 2 and I have 1 and 2, right? The ways for 1 and 2 to go are this: they can either go alone or they can go in pair, right? If 3 is deciding to go alone and he's not pairing up with someone, then the total number of ways would be for these two only, right? I hope you are getting this point. This is very important, that since 3 is deciding to go alone, right? 3 is deciding to go alone, and since 3 is deciding to go alone, he's dependent on these two numbers which are n minus 1, right? This is two numbers, right? These are two numbers, my 1 and 2, and the total number of ways for 1 and 2 to go are 2, which are these two, right? These two are the ways for 1 and 2 to go. Let's see this okay. I have n equals to 3. I have 3 numbers. Okay, I am saying that I know how 1 and 2 can go, right? 1 and 2 can go either they can go alone or they can go in pairs. Okay, now 3 decides to go alone, right? 3 decides to go alone. If 3 is deciding to go alone, he is only dependent on the last two numbers or all the last numbers, because since he is going alone, he will be pairing up with the number of ways of 1 and 2, right? Is there any other way that 3 can go alone and we can have a different number or different number of ways than this, right? These are my ways. These are my ways. These only are my ways for 1 and 2 only, right? These are my ways for 1 and 2 only. But since 3 is deciding to go alone, now 3 is dependent on these ways only, right? I hope you are understanding this point, that since 3 is deciding to go alone, he is dependent on 1 and 2 and the number of ways for 1 and 2 only. Okay. Now, I hope you understood this point. We are going to see this for n equals to 4 as well. So this will be more clear. Okay. Let's say this is for now 3 is going to go in pairs, right? If 3 is deciding to go in pairs, 3 can either pair up with 1 or 3 can either pair up with 2, right? If 3 pairs up with 1, then the only person that is left is 2. So he will go alone. Okay. If 3 pairs up with 2, then the only person left is 1. So 1 will go alone. Okay. Is there any other way? Is there any other way? 3 cannot pair up with someone else, right? So the only other way would be something like 1 and 2. 1 and 2 pair up and then 3 goes alone. Right? But this has only been the way if 3 goes alone, right? I've already written this here. This is the same thing. So we see that if 3 is deciding to go alone, it is dependent on the last n minus 1, on the last n minus 1 friends, right? If my current friend is deciding to go alone, it is dependent on the ways of n minus 1 friends. Okay, if he is deciding to go alone. But if he is deciding to go in pairs, we will derive a formula for that. Okay, so what are the ways that we have seen? These are two ways and these are two ways. So my answer here would be 2 plus 2, which is 4. Right, this would be my answer. Now let's see this for n equals to 4. How would be my answer? What would be my answer? For n equals to 4, we would have 4 friends. We would have 1, 2, 3, and 4. Okay, we would have 4 friends. Now, for 4 friends, 4 is deciding to go alone or 4 is pairing up with someone. Okay, if 4 is deciding to go alone, what did we see in the last for n equals to 3? We saw that 4 is going to be dependent on n minus 1, which is 3 here, right? So it is going to be dependent on on the 3 friends, on these 3 friends. So let's see if this is actually the case. Okay, let's see what will happen. Let's say 4 is deciding to go for 1, 2, and 3. And what are the ways for 1, 2, and 3? Right? 1, 2, and 3 can either go alone, or 1 and 2 can pair up and 3 will go alone. Okay? Or 1 and 3 will pair up, 2 will go alone, or 2 and 3 will pair up, 1 will go alone. Okay? These are the ways for 1, 2, and 3. And now, since 4 is going alone, 4 can pair up with these ways. Is there any other way where 4 is alone, but it is not written here? No, right? The only way where the only other ways for 4 would be if 4 pairs up with someone, right? All of the ways where 4 is alone have already been written here, and these are the same ways which are dependent on n minus 1, right? The ways of n minus 1 friends. So I can say that if 4 is going alone, it is dependent on the ways of n minus 1 friends, right? I can say this very clearly. But what if it is pairing up with someone? Let's see. Let's say I have 1, 2, 3, 4, something like this. Now, 4 can either pair up with 1, 4 can either pair up with 2, 4 can either pair up with 3. Right? How many friends are here? There are n minus 1 friends, right? I have n minus 1 friends. So 4 can pair up with n minus 1 friends, right? 4 can pair up with n minus 1 friends. So let's see what will happen if 4 pairs up with someone. Let's say we have 1, 2, 3, and 4, and 4 pairs up with 1. Okay, 4 pairs up with 1. If 4 and 1 are paired up, we would have 2 and 3 left, right? 4 and 1 are paired up, so 4 and 1 are paired up, and we have 2 and 3 left. So what will happen for 2 and 3? For 2 and 3, there are going to be 2 cases, because we have already discussed for 2, if there are only 2 friends left, then there are going to be only 2 cases, which is either 2 can go alone, 2 and 3 can go alone, or they can go in pairs, right? And this is the case where 4 is paired up with 1. So this is going to be my answer for if 4 is paired up with 1, and the rest of the ways would be for n minus 2, let's see this for if 4 is paired up with someone else. Okay, so let's see this for, we have 1 2 3 4, and now 4 decides to pair up with 2, right? If 4 and 2 are paired up, 4 and 2 are paired up, we would have 4 and 2 here, 4 and 2 here, and 4 and since 4 and 2 are paired up, we have 1 and 3 left, right? 1 and 3 are left, and since 1 and 3 are left, what are the different ways where 1 and 3 can go? They can go either alone or they can go in pairs, right? So this would also be my answer. If 4 decides to pair up with 3, this is going to be my third case. If 4 is deciding to pair up with 3, 4 and 3 are pairing up. So if 4 and 3 are pairing up, either 1 and 2 can go alone or 1 and 2 can go as pairs. So what do we see? We see a pattern here, right? We see that if 4 is going alone, it is dependent on n minus 1 friends, right? If 4 is pairing up, we see that 4 can, or if let's say this is for n, right? If n is pairing up, n can pair up with n minus 1 friends, right? N has n minus 1 options to choose from, right? 4, for n equals to 4, 4 can pair up with 3 people, 4 can pair up with 1, 4 can pair up with 2, 4 can pair up with 3. So for n, it can pair up with n minus 1 friends. We know that. Okay. What is the next thing? The next thing is that the number of people remaining, that if 4 pairs up with someone, let's say we have 1, 2, 3 and 4. If 3 and 4 pair up, we have n minus 2 people left, right? We have n minus 2 people left, and we see that for n minus 2, for n equals to 4, n minus 2 is 2, and the number of ways for 2 are 2. So we see that if n pairs up with n minus 1 friends, so after this, after n is paired up with someone, we would have n minus 2 people left, right? N minus 2 friends left. So this would be dependent on n minus 2 friends. So what is the formula that is going to be derived? Okay, so let's see here. We can say that if n minus 1, if my single n is going to pair up with n minus 1 friends, and after pairing up with n minus 1 friends, he's paired up with someone, so there are n minus 2 people left, right? So this will be multiplied with the ways of n minus 2 people, right? We can see that the since it is dependent on n minus 2 people, since they are left, so the total number of ways of n minus 2 people, and my n is pairing up with n minus 1 people. After pairing up, there are n minus 2 people left, so it is dependent on n minus 2 people. So this is going to be my formula for n if it is pairing up, right? If it is going alone, I can just simply say it is n minus 1. Since it is dependent on n minus 1 people and it is going alone, this is going to be my formula. And for f of n, the total answer would be the sum of alone and pair. I hope you understand this part. This part means that if n is going alone, it is dependent on n minus 1 people. We have already seen that if n is going alone, it is dependent on the sequences of 1, 2 and 3, right? If n is pairing up with someone, n can pair up, n can pair up with n minus 1 people, right? N can pair up with n minus 1 people, and here we know, since n can pair up with n minus 1 people, n minus 2 people are left, n minus 2 friends are left. And since n minus 2 friends are left, they are going to go in their own way, or they are going to go in their own number of ways, right? N minus 2 friends are left, and they are going to go in their own ways, right? So my answer would be this. My answer would be that if it is going alone, this n minus 1 would be my answer. And if it is going in a pair, then n minus 1 times the function of n minus 2. Okay, I hope this part is clear. Now let's try to understand, let's try to derive the formula for 4. Let's say for 4, my answer was 1, 2, 3, 4. Right, so I got 4 from here. And how many ways are here? We have 1, 2, 3, 4, 5, and 6. So we have 6 ways here. So the total ways are 4 plus 6, which is 10. Right, 4 plus 6, which is 10. So total ways I got here was 10 for 4. Let's see if I can get 10 using the same formula. Right, for n minus 1, here, if I use this formula, let's zoom out. Let's erase this. Right, we are here and we see that for n equals to 4, n equals to 4 if n is going alone, right? So that would be f of n minus 1, f of n minus 1, and that would be f of 3, right? What would be f of 3? F of 3 is 4. So if n is for n equals to 4, if it is going alone, my answer would be 4 plus, this is for alone, right? If it is pairing up with someone, so that would be n minus 1, which is 3 times function of n minus 2, which is 2, right? What is function of 2? 2 gives me 2. Here function of 2 is 2, right? So my answer would be 4 plus 3 times 2, which is 4 plus 6, which is 10. So my answer is 10. And we are getting the same answer when we did the, we found the answer in the brute force way. Okay. So I hope you understand this question and I hope you are getting what the formula actually means here. Okay. Let's do this for n equals to 5 and then we'll code the question. Okay. So for n equals to 5, my n minus 1 would be 4, which is 10. Right, so let's write it like this. For f of 5, f of 5, f of 4 plus n minus 1, which is 4 times f of 3. Right, this is when it is pairing up with someone. This is when it is going alone. Right, if it is going alone, then the number of ways are 10 plus 4 times f of 3. F of 3 is 4. So this gives me 16. 10 plus 16 gives me 26. So here my for 5, my answer would be 26. Okay, so this is going to be my answer and this is my formula. Now let's try to code this question. Okay. Okay. So what is the first thing that we are going to do? Let's make a DP array. And also let's say that if n is less than equals to 2. Okay, if n is less than equals to 2, then I can just simply return n, right? If n is less than equals to 2, then I can simply return n. This is the kind of base case that we are taking. Also now let's run a loop for I is in let's say range, and this will go till n plus 2, right? We are going to fill our DP array, so it would be dp dot append. We are giving it a size. Now the first value is 1, right? These are our base cases. The second value is 2, and we are going to start our loop. Now why we are starting a loop like this? Because we know these two base cases are like very common. So we just have to handle the cases when it is greater than 3, right? So we are starting our range from 3. So it will go from 3 till n plus 1, right? Now we will see if, or we are going to say that it is going to pair up with someone, right? So dp of I would be dp of See, this is n minus 1. So dp of I minus 1 plus I minus 1 times dp of I minus 2. This is my code, right? This is the same thing. And since after this loop has run, my answer would be at the last part, right? So it would be at dp of n. This is capital N. Okay, this is my answer. This is my code. Let's try to run this. Okay, it is accepted. Let's submit this. It is also submitted. So I hope you understand this question. This is a very interesting question. If you don't understand any part, you can just rewind back and watch the part which you don't understand. Thank you for watching. Please don't forget to like, share, and subscribe. Thank you.